All right, so in this topic, we're going to be finding the equation of a line. Previously, we were given the equation of a line and we either found the x and y intercept or we graphed it. Okay, but this time we're going to be going backwards. We have to come up with the equation of the line. So, just as a quick refresher, the equation of a line, we want to write this in slope-intercept form. So you want it in this form, y equals to mx plus b. Okay, this is the slope-intercept form. But to get it in this form, anytime the directions are find the equation of a line, you start with this form, which is called the point-slope form. You start with the point-slope form, and that helps you find the equation of the line in slope-intercept form. Okay, so your first example, and I'll talk you guys through the steps as we're doing the example. Your first example, we want to plot the points -1, -3, and 3, 5, and find the equation of the line through the 2 points in slope-intercept form. So what are our points? My first point is -1, -3. So that's going to be down here. My second point is 3/3, 5. That's going to be up there. So for slope-intercept form, y equals to mx plus b, we need two things. We need the slope and we need the y-intercept. Well, if I look at the equation of that line, the slope is pretty easy to find. The slope is just the rise over the run. So, how much am I going up? I'm starting here. I'm going up, let me count. I'm going up 1, 2, 3, 4, 5, 6, 7, 8. I'm going up 8 units. How much am I going across? I'm going across 1, and then 2, and then 3, and then 4. I'm going across 4 units. My slope is rise over run. So my slope, 8/4, is going to be 2. So that part's easy. So what do I need this point slope form for? I know I can find the slope very easily. Well, I need it because if I look at my line, I don't know what my y-intercept is. My y-intercept looks like it's somewhere close to -1, but I can't just estimate that. I have to find the exact value of the y-intercept, okay, or the b. So to get the y-intercept, we're going to start with the point-slope form, okay, and then we're eventually going to end up with this, which is the slope-intercept form. So let's go through the steps. Step 1. In your media notes, it says, Step 1, find the slope and plug it into the point-slope form equation. Okay, so we can find the slope by counting the way we did, but we're not going to be doing that in actual problems. This was just to show you guys what's going on. In an actual problem, you would use the equation of slope, which is y2 minus y1 divided by x2 minus x1. Okay, so y2 minus y1, that's 5 minus -3, divided by x2 minus x1, that's 3 minus -1. 5 minus -3, that's 5 plus 3, which is 8. 3 minus -1, that's 3 plus 1, which is 4. 8 divided by 4 is 2. So my slope is 2. What do I do with that? Once I know what my slope is, I'm going to plug it in to the point slope form. So that's going to be y minus y1 equals 2 times x minus x1. Now what? I still have to find the y-intercept, or the b value, which is the y-intercept. So the second step is you pick a point and you plug it in. So you can either pick the point -1, -3, or you can pick the point 3, 5. You can pick either of these points. It doesn't matter which one you pick, you get the same answer. So I'm going to pick the first point, -1, -3. Where do I plug it in? Well, you replace the x1 and the y1 values with this point, -1, -3. So what does that look like? Instead of y1, I'm going to put y minus -3. That's my y value, because I'm picking that point. That equals to 2 times x minus x1, which is also a negative number, so it's going to be x minus -1. All right, so let me simplify that. These become positive, so this becomes y plus 3 equals 2 times. These also become positives. There are 2 negatives in a row. This becomes x plus 1. Okay, so I'm going to get y plus 3 equals 2 times x, that's 2x, And 2 times 1, that's 2. So I get y plus 3 equals 2x plus 2. But in slope-intercept form, I need the y by itself. So I'm going to subtract 3 from each side. And if I do that, my equation becomes y equals to 2x minus 1. Now the reason I had you guys start with the plot is we want to see, does this equation make sense? Okay, well, is my slope equal to 2? Yeah, because that's 8 over 4, which is 2. Is my y-intercept equal to negative 1? If you look, it's actually very close, even though it was just a sketch, it is actually negative 1. So that equation makes perfect sense. Another way to think about the slope 2 over 1 is you can pick any point on the line. Let's say I start with this one. If I go up 2 and I go across 1, I'll get another point. From here, I go up 2 across 1, I get another point. I go up 2 across 1, I get another point. That's what the slope indicates. So that's my equation. So the steps, first find the slope, plug it into the point slope form, then plug in a point, and then solve for y. And you get your equation in slope-intercept form. All right, next example. The next example says, plot the points 2, 5, and negative 3, 8, and find the equation of the line through those points. All right, start from scratch. Okay, our points are 2, 5, and negative 3, negative 3, 8. These are our points. So what do we do with this? First, we're going to plot the points. So 2, 5, that's going to be 2, 1, 2, 3, 4, 5. That's my first point. My second point is negative 3, comma 8. So my second point, I'm going 3 to the left, and I'm going 8 spaces up. So it's 1, 2, 3, 4, 5, 6, 7, 8. It's going to be right there. And then I'm going to connect the 2 points. Make a little line. What do I need to have my line in this form, in y equals mx plus b form? Well, first I need a slope, which I can find. Now the y-intercept, I can't find that just by looking at the line. It looks like it's up there somewhere, so it looks like it's approximately 1, 2, 3, 4, 5, 6, somewhere between 6 and 7. It could be like 6.5, but we can't approximate, we need an exact value. So for that, we start with the point slope form. Okay, let's go through the steps. In your media notes, your first step is find the slope and plug it into the point slope form. So my slope is y2 minus y1 divided by x2 minus x1. 8 minus 5 is 3, negative 3 minus 2 is negative 5. And I'm going to move the negative to the middle, so this will be negative 3/5. Okay, so my slope is negative 3. I'm going to plug that in. Got y minus y1 equals to m times, well, m is actually negative 3/5, so negative 3/5 times x minus x1. That takes care of the slope. But to find the y-intercept, we have to keep going. We have to plug in one of these 2 points, and it doesn't matter which one you plug in. I'm going to plug in the first one again, so I want to pick 2, 5. Where do I plug this in? I plug it in to the x1 value and the y1 value. So instead of y minus y1, my y value is 5, so I'm going to put y minus 5. That equals to negative 3/5 times x minus x1. Well, my x1 value is 2, so that's going to be x minus 2. Now we're going to be dealing with some fractions, so get ready. Left side is fine, it's y minus 5. On the right side, you multiply negative 3 over 5 times x, and this will give you negative 3 over 5x. Then you multiply negative 3 over 5 times negative 2. So, word of caution when you multiply fractions, what I would recommend, let me actually move this down a little bit. So this was y minus 5 equals to negative 3 over 5x. So far, you just multiplied the negative 3/5 times x. When you multiply a fraction with an integer, make the integer into a fraction. So take the negative 2 and put a 1 underneath that. Make it into a fraction. -3 times -2, that's going to be +6, and 5 times 1 is going to be 5. When you multiply fractions, you do not need a common denominator. You multiply the numerators, multiply the denominators, and you're done. So -3 times -2 is 6, which is why it helps to put a 1 underneath so you know what the denominator is. And then 5 times 1 is 5. All right, and then finally, you want to get the y by itself, so we are going to undo subtracting 5 by adding it. And we're going to add a 5 to this side as well. But when you have a fraction, now we're adding, not multiplying. So you need a common denominator. So this 5, it's like 5 over 1. Okay, so what do we do with that? We're going to multiply the denominator by 5 and the numerator by 5 to get an LCD. So my new problem becomes y equals, you have negative 3 over 5x, that's my slope, plus 6 over 5, plus 5 times 5 is 25 over 5. Okay, I need a common denominator there. If I add 6 plus 25, it gives me 31. Denominator doesn't change, so I'm going to erase that. I'm going to write that as 31 over 5. Okay, so this is 25. 25 plus 6 is 31, so I get 31 over 5. Now, does that make sense? 31 divided by 5, if you convert it to a decimal, that's like 6.2. Remember we said our y-intercept is somewhere between 6 and 7, so it makes sense that the y-intercept is 6.2. So our plot and our equation, they both make sense. All right, one more example. Plot the points 3, 2, and 3, 5, and find the equation of the line through those 2 points. So let's start with the plot. Okay, it says plot the points 3, 2, and 3, 5. Okay, so if I plot them, here's what happens. Point 3, 2 is going to be here. And the point 3, 5 is going to be a little bit above that. My x value is still the same. So 3, 5 is going to be there. That's my line. Notice it's a vertical line. Okay, but regardless, let's go through the steps anyway. The first step is find the slope. Okay, so our slope is going to be y2 minus y1 over x2 minus x1. So that's 3 over 0. But if you divide by 0, guess what? That is undefined. 3 divided by 0 is undefined. How do I plug in an undefined slope into point slope form? I can't. Okay, but here's what we know. Remember we learned from the previous video that if you have a vertical line, all the x values are equal to 3 in this case. So this is like 3, 2, this is 3, 5, this is 3, 3, this is 3, 4, this is 3, 0, that's 3, negative 1. All the x values are fixed at x equals to 3. So that's just the equation of our line, x equals to 3. Any vertical line is going to have an equation of x equals and whatever the fixed x value is.